Hey guys, welcome back to the video. Today we'll be talking about the Bohr-Rutherford diagram and the Lewis dot diagram for fluorine. First, I will be talking about the Bohr-Rutherford diagram, then I will get into the Lewis dot diagram. So the Bohr-Rutherford diagram has nucleus which has two subatomic particles, the number of protons and the number of neutrons, and it is surrounded by these rings called the shells. Within these shells, there are certain rules to follow. For example, the first shell should contain 2 electrons, the second shell should contain up to 8 electrons, and the third should contain up to 18 electrons. Altogether, these diagrams should look similar to planets orbiting the sun. Next, we'll be getting into why the Bohr-Rutherford diagram was denied. Although Bohr-Rutherford diagram was helpful to understand how electrons orbit the nucleus stably, it had major problems. One of them is that it states electrons have known radius and orbit. This breaks the Heisenberg's uncertainty principle, thus it is considered to be incorrect. The Bohr-Rutherford diagram was invented in March 6, 1913 by Niels Bohr. Next, we will be getting into the Lewis dot diagram, which is actually one of the special diagrams comparing with the Bohr-Rutherford diagram. The Lewis dot diagram was created to represent the number of valence electrons of an atom within a molecule. The Lewis dot diagram was extremely helpful, and by learning the diagram can help one find the reactability of a molecule and the interaction with other molecules that is presented. The diagram consisted of two main things, the number of valence electrons and the element symbol. The valence electrons were shaped like a dot which surrounded the element symbol. So the finding of the valence electrons are pretty simple. It could be found within the groups. So for example, fluorine is found in group number 17, which means that it has a valence number of 7. It is also the outer layer shell of the Bohr-Rutherford diagram, so the last shell or the last ring of a Bohr-Rutherford diagram. And finally, the Lewis dot diagram was invented in 1916 by Gilbert Lewis. Before we get started with our drawings of Bohr-Rutherford diagram and the Lewis dot diagram, we need to understand certain things, so it might be helpful with drawing the diagrams. So the number of neutrons and the number of protons are the subatomic particles within the nucleus, or you could call it the brain of the atom. The atomic number, which is equivalent to the number of protons, defines what an element is. For example, an element has 9 protons, it is fluorine, and if it has 5, it's considered to be carbon. This also helps provide the identity of an atom. Since we're on the topic of fluorine, why not get a quick fact about it? Fluorine is the most reactive substance in the periodic table, and it attracts electrons easily. With this in mind, let's get into the video in 3, 2, 1. Hey guys, today in this video, I will be teaching you how to draw a Bohr-Rutherford diagram and a Lewis dot diagram for fluorine. So before we get started, we need to look at the number of period or the period number the fluorine goes under and its group. So fluorine goes under a group called halogens right here, which are highly reactive, and fluorine's gas at room temperature, by the way. It is group number 17. And it is period number 2 or row number 2. Okay, let's get started. So first I will be drawing the Bohr-Rutherford diagram and then the Lewis dot diagram. Okay, this is how a Bohr-Rutherford diagram should look like. We need 3 main things in order to draw a Bohr-Rutherford diagram. So I use a pen method to organize my things that we need. So the number of protons, the number of electrons, and the number of neutrons. The number of protons is the same as the atomic number. So for fluorine, the atomic number is 9, which can also be seen in the periodic table. So 9, and it has atomic mass of 18.99 or 19. So 19 subtracted by 9 will give you the number of neutrons. So protons is 9 because it's the same as the atomic number. The electrons is the same as the protons. so 9, and the neutrons is 18.99 subtracted by 9, so 10. So there's 10 neutrons for fluorine. So this is our Bohr-Rutherford diagram. We should have 2 shells and 1 nucleus. I'll explain the reasonings behind why that is the case for fluorine. So on a periodic table, fluorine falls under row number 2 or period number 2, which means it has 2 shells. Okay, so these circles over here, forget the nucleus right here. These shells over here are the shells. Okay, the circles are the shells. So inside our nucleus, we have 2 main important things. So the number of protons and the number of neutrons. So the protons are always positively charged, and the neutrons have no charge, so they're neutral. So this is how you write them. So 9 protons, which are positive, and there are 10 neutron, which is neutral, so you add a 0 right here. So this is how your brain should look like, or it's called a nucleus in science. Okay, so for a first shell, it should have 2 electrons. So the electrons orbits the shells. Okay, so the first shell should have 2 electrons, the second should have 8, and the third should have 18. Since we only have 2, it should be 2 and 8. Okay, so you should always go by clockwise to ensure that you're doing it right. So 1, 2. So clockwise for the second one. So 3, 4, 5, 6, 7, 8, and 9. The reason why we drew 9 electrons is because there's only 9 electrons for fluorine. Okay, so this is how your Bohr-Rutherford diagram should look like. And let's draw the Lewis dot diagram, which is fairly simple when we know our valence electrons. So for our valence electrons, as said before, it's a group number. So fluorine falls under group number 17, which means has valence of 7 or valence electrons of 7. If it's fluorine, it has 6, so you can easily find it with the group number. So there's 7. So there's 7 valence electrons. So I'm just writing this to represent it. You shouldn't write this in real case. I'm doing it to explain it to you guys. So you write the element symbol, which is F. Then we plot the valence on clockwise, similarly to the Bohr-Rutherford diagram. So 1, 2, 3, 4, 5, 6, and 7. Again, you could draw this any way you want, but if you draw or use the clockwise, it will be much helpful and it will ensure that you're doing it correctly. So also there shouldn't be any space over here. So this is how you draw the Bohr-Rutherford diagram and the Lewis dot diagram for fluorine. So before we finish off the video, I want to explain some things. So protons are obviously positively charged, electrons are negatively charged, and neutrons has no charge, so it's neutral. The protons and the neutrons go under or inside the nucleus, and the shells are orbited by the number of electrons. Okay, the number of protons and the electrons are the same. So the way that we got our neutrons is by subtracting the atomic mass number by the atomic number. So 19 minus 9, 10. Okay. For our Lewis dot diagram, we need the number of valence electrons. So in our periodic table, there's 17. So fluorine falls under group 17 halogens. So there's 7. So 7, and you plot them like that: 1, 2, 3, 4, 5, 6, 7. And it could also be found on the outer layer of the Bohr-Rutherford diagram. So see, 1, 2, 3, 4, 5, 6, 7. So this is the outer layer of the Bohr-Rutherford diagram is the number of valence. So this is the one way to find it. The other way is using your periodic table. Thank you for listening to my presentation.